Okay. Good morning, everybody. Happy to meet you today um, on Kubernetes for absolute beginner. So I'll come briefly on camera so that you guys see the short guy behind the scenes. So, there's my time, give me a second. Yeah. So today I'll be having a discussion with you, literally on Kubernetes, and then yeah, we hope it's going to be hands-on and materials will be shared, questions will be asked, and then yeah, let's get going. So, so if you see this particular introduction that we're going to do right now, we're not going to keep talking a lot of theory because that's not the real thing. The real thing is actually to get our hands on going. So just to go through this, just some random TDF thing we want to go through together. So yeah. So Kubernetes, I think for those of us who are either coming from front end, back end, DevOps, SRE, um, we've all in one way or the other probably heard about Kubernetes, and they're coming from containerization background, that is with Docker, Docker Swarm, maybe Ranker, or like basically anything. But I think the most popular one is Docker. I think if you have not had any experience with Docker before, that's fine. That's fine. Nothing wrong with that. But the fact that you cared about Docker is just a good sign. And yesterday in our reminder, I think no, the WhatsApp group. I'm not sure if everybody's on the WhatsApp group. So, Mumin, can you share that WhatsApp group on the chat so that in case the call ends, we can still dump the resources there for people to have access to them. Yeah. So yeah, we made a prerequisite for this webinar. That is, if you want to have a hands-on on this, to have Docker installed. To have Docker installed, that's very nice. I think some machines may take a couple of minutes, and then I shared a link on how to install Docker on the WhatsApp group for the three major architectures. Um, I mean, operating systems. Yeah. That's for Linux, macOS, and that's from Windows, right? So let's just jump onto it. So as I said, okay, yeah. So moment you can share the WhatsApp group. So Mr. Tawfiq, if you look on in the chat, there's a WhatsApp group there. Just click on it, and you will be able to join the WhatsApp group. Thank you. Cool. Yeah. So as I said, we are going to keep this snappy. That is on the theory part, so we can get to the doing part, right? So basically, what are containers? We have virtual machine versus a container. So what the virtual machine simply means, I think, if you have ever tried before in the past, is just having a server, install all your packages or dependencies and binaries, right? If it's a web server, put your web server on it. If it's Apache or nginx, get it going, and that's it. And if you want to scale, do the same thing to multiple of such servers. This server could be virtual, it could be physical, like bare metal, physical, but still, it's still like a machine. But here, the virtual here simply means that most likely you want to use a cloud, or if even you have a physical machine, you probably want to have a hypervisor, and these hypervisors basically are like an isolated form so that you have another machine inside your machine. But the whole point here is just that if you look at the two pictures, right, the most important part is the last layer, that is your binaries and that's of your apps, right? So here on top of the hypervisor, which basically is a machine, right? It's just a whole machine on its own. So if you look at Windows users, you have a VM for Windows users, right, where you can use this particular hypervisor and take a chunk of your machine. Yeah, this of us in the ground. It's raining here. So what I mean by a chunk of your machine, I mean the resources. So if you have your own machine, let's say 16 gig, you have to like assign 8 gig to the hypervisor. So the hypervisor is taking that amount of space so that it can just render to you the whole machine that you can do what you want to do. Unlike a normal container like Docker, here you are not given a chunk of your machine. I mean, for Mac OS users, you also realize that Mac OS do not natively run Docker. It has to do that in a form of, I think, KVM, right? Also create a kind of like a VM for you to run it. Unlike like Linux machines, if you see those who are running Linux, that one is much more easier and simpler. Like Docker is just run as a binary and then it shares the complete resources on your machine, right? So a bit of like deviation for Mac OS and Windows here as well. But then the line thing is that you have an engine which we call the Docker that you can then sit on top of that and distribute your virtual machines, which in this instance we what we call the containers. And then within the containers, the apps. So the apps here basically are just like containers. Let me put it that way. Yeah. So containers on cloud. So how to run and manage containers in the cloud. So what happens is that we manage more containers in different nodes. So node here basically means the virtual machine, right? I mean, I don't know why by the tech world, like people could always use much more simpler words, but it's like the trick is use the words that are techy and then people get more confused again. So yeah, so different nodes here just means virtual machines, right? Literally virtual machines. So you run more instances of the same container. So let's say if you have your nginx web server, exciting. We are going to actually deploy this. We are going to deploy some apps on our Kubernetes cluster. I mean, I've forgotten to start with that. I mean, that's the core objectives. We are going to spin up a Kubernetes cluster with the utility tool. We are going to deploy applications. We'll try Apache. We'll try maybe Nginx. We'll try maybe HashiCorp Echo image. That will build our own Docker image, right? Containerize it, push it to the Kubernetes cluster, and then voila, we have it on the not on the internet but on our own local machine. So yeah, so containers on the cloud. So what I just said right now is exactly the same thing that they're talking about here. You have your nodes, that's the machines. Then you kind of like deploy your application. Let's say this time Nginx, and then you want to scale the Nginx instances by making them plenty so that traffic can be distributed based on the kind of traffic flow you want to use, whether it's round robin or whatever you want to do. And then you scale up or scale down the resources based on the load. That is, if there's more traffic, then increase the number of replicas. Basically means increase the number of your containers so that they can each receive a request from the public internet, or if it's a local service from the local service or local application. Let me put it that way. So you have load balancing, you have lifecycle container. That is how the container is created, deleted, and then restarted or redeployed, then and so on and so forth. Now, what is Kubernetes? We'll take that snappy again. So it's an open source system for automating deployment, scaling, and management of containerized applications. Again, another goal and objective. We are going to do this. We are going to the first part will be the automation. I mean, we're not going to have a full CI/CD pipeline, but we will do the automation on our terminal, whereby we deploy the application, go and edit the application, and then build it to deploy it, and you see the flow, right? And then yeah, that's all about. That's basically Kubernetes. You want to scale and manage your application in a much more in an automated way. Let me put it that way. So container runtime and container runtime standard. So these guys, I don't care. You don't care too. Nobody cares about them. This is like going into much more the deeper part about how the engine works, the Docker engine works. I don't think we're going to go into that. Pod and bits, we're not actually going into that much, but just a brief one. So pod just means here it's like your Docker container locally on your machine, right? So when we say pod is like the equivalent of a Docker container this time around in Kubernetes. So as again, Docker is almost similar to Kubernetes. They share a lot of similarities, just that the naming and how they work is different. So here they say a pod consists of one or more containers which share an IP address, access to storage, and then namespace. So most at times you have a pod running one container. So you find people calling pod containers or containers pods. That's most likely going to happen. But technically and deep down, pod is just like a layer or a capsule that can manage multiple containers. So I can deploy my Nginx container and maybe Apache container in the same pod, right? So technically, I'm having two containers within the pod, but these pods have to be related in some way so that they can share networking, they can talk to each other within the namespace without any network policies or that. But most of the times in my working experience, you're most likely to find one container per one pod. So you find the names being used like or interchangeably. So pod, container, yeah, that kind of thing. So in the picture that you can see that we have a pod, inside the pod we have a container, and these two containers basically can talk to each other and scale as well. Now we move into what a Kubernetes cluster is. Again, this same notation happens in a lot of, I think, software, or will I say, yeah, the software domain. You have like a master, you have a slave, right? So master means the one that controls the OS, that's a slave. I mean, same logic is used in Rabbit MQ clusters. You have a master, you have the slaves as well. The same term is used in, I think, most of the QA services. RabbitMQ, you find the same thing. If you go to Confluent, right? If you go to Confluent Kafka, I mean, if you even go to the open source Kafka itself, you find master, you find slaves as well. What again? I think, yeah, that's it, basically. So the next one is deployment. We're talking about deployment. So basically, deployment is the one that manages how your application is deployed. We'll come to it. Then we go to stateful set. So stateful set are also type of it's a type of resource, or let's say a type of API call that you can make in your Kubernetes cluster. That is quite different from deployment because those ones most of the times have to do with like most especially database connection. So you want to have a sequential way of creating and deleting your port or your containers. So yeah, so we go to service. So service here basically means, I mean, as you keep on hearing, a microservice kind of. So service is like a layer that allow you to talk to your pod or containers, right? And the service is just like an outside layer. So let's say the door, right? Let's say human beings are in the room and the human beings are the pods, right? The house, let me say the human beings are the containers. The house is the pod, right? Now your door, or let's say your veranda, can be your service. So that's like an entry point. So if I want to enter into that house, I need to knock or I need to pass the veranda and knock on the door. So let's say the veranda and the door is your service, then the house is the pod, then the human beings in the house are the containers. Literally the same thing. But we're also going to have the same service, so it's a way of exposing your application, and it has different formats that you can always say different types. The load pod, the load balancer, and then I think, and then other two ones I think are not much used. Cool. So the last one is the ingress with regards to here. So the ingress here means that it's just like giving a public it could be public, private, but here it means access from the internet. So service can be within the cluster, right? But when ingress comes in, it just means that you want someone to have external access. So an API object that manages external access to the service is in a cluster, typically HTTP. So if I come from the internet and just type ktechhub.com, so ktechhub.com, that is the public internet. Then when I hit, it needs to route ktechhub.com and then do the routing towards a service. I say, hey, GitHub, it goes to my cluster. I'm looking for GitHub. So you go to the ingress resource or the ingress file and say, hey, I'm looking for GitHub, and GitHub is connected to this service called GitHub service. Can you find it for me? Then GitHub service say, hey, respond. Yeah, I'm the one. Then it takes him to what? To the door, that is the port, and then to the human beings inside the port, that is the container or the containers. So config map and secret is not right now and nice to have. A system volume, so basically like mounting a storage so that you can use a disk on your containers, and then literally that. So I mean, yeah, that's it. A lot have gone, but I think getting your hands dirty still is the most important part. And then if there is any question, we'll take it. Else, we would switch to go and do some practical work. Yeah. So let's give some minutes. If there's any question, we take it. Yeah. Well, so while you have preparing your question, if it's possible, or if they're available, I'm just getting my working environment ready so that we can get our hands on something. Okay, so let me see. Let me share my screen so we can go in. Second. Okay. Okay. So we're sharing again. Okay, so cool. So we're now going to do some hands-on over here. Yeah. So as again, so before we start, let me share the link. You can follow together, but I might be a bit quicker so that we don't spend much time on this. So I'm going to share the link here. You can clone the repository uh, or fork it to yours, and then you can follow through. If you are quick enough, you can follow the entire flow. Else, you can come back later and do it. So that's the repository pasted on the group. That's what you're going to be following, basically. Cool. So again, just to give you some exciting moments for this, Kubernetes is a very, very, very good tool, and trust you, me, guys, it has a very good career in that you can have from. It's very rewarding. It has a lot of potential. It's not going to die anytime soon. Like the way AI is killing some things, Kubernetes is here to stay. So if you can actually take it very serious, I think you can have a very wonderful career with that. And the fact that we have fewer people going into it because, like, yeah, people like operations more than like getting hands on. So yeah, that's just some few words on that. So let's get started. So in this particular tutorial, we're going to just demonstrate how Kubernetes work and then how we deploy application to Kubernetes. So in this webinar, we are going to use a package manager called Kind. So Kind means Kubernetes in Docker, right? So we can just Google it so you can read about it. It's called Kind Kubernetes. So Kind Kubernetes is just a tool that allows you to basically spin up your own Kubernetes cluster locally, right? So mostly, if you want to work with Kubernetes, you need to actually get some virtual machines, bootstrap it together, basically connecting them together with maybe a tool like KubeADM, like a whole bunch of things that you need to do. But these guys, they created a utility under the hood that will use your Docker containers. That's why yesterday I put on the WhatsApp group, have Docker as a prerequisite so that they can use your Docker engine, basically, and then simulate your containers like your virtual machine. So that's basically what we're going to do. So I'm pasting that one if you're curious and want to read more about Kind. So it's called Kubernetes and Docker. So it uses your Docker containers and simulate them like they are like virtual machines. So that's very nice and amazing. So you don't need to go to your cloud provider like Amazon or Azure and spin up like real virtual machines, and then get a tool like Kubectl, which will take you like minutes, if not hours, to then tie them together. Like it's just headache. So that's what these guys are simplifying. So we're going to use that utility, and I know maybe some of you might have heard about its alternatives. We have what we call Minikube, doing almost the same thing. You have K3D, you have K Tray, I think a couple of them, and then K6 also. Yeah, there are a couple of them. But I love Kind because it's very, very much more smoother, and then faster as well. So we're going with this guy for now. We can explore the others. So prerequisite, you can install it with a Pocket Manager. If you're on macOS, just do pre-install Kind. If you're using MacPorts, just you can use the pseudo self-update and pseudo port install Kind. Windows guys, you can go with Choco install Kind as well. So yeah. So if you want to do the direct installation from a binary, then you can follow the below architectures for Linux, right? AMD and that of ARM. Just copy one of them, right? And then yeah. So here is just going to extract your architecture name. If it's AMD, that's 86 architecture, and then just install it for you, right? On Mac OS, pretty much the same thing for those using the old Intel, and then for the new M1 guys, and then architectures going on. Windows PowerShell, the same thing, just copy it and paste it. After that, you can then verify. So I've done that so that we get going quicker. I've done mine. So if I do Kubernetes, so if you can see my screen, sorry, if I do kind version, then you realize that I'm running on the Go version 22.0. Perfect. Now let's get going. So this utility is now going to bootstrap whatever we are doing on our local machine using our Docker containers and simulate a real Kubernetes environment. And trust me, this guy, they say it's used for testing, but people are using it for production. People are using this guy for production because it's really powerful, right? And then yeah, that's how trustworthy it is. Cool. So if you do Kind and with your helper flag, you can see all the arguments that you can pass through it. So we can build that is, you can build an image. It does the shell completion. We can create a cluster, this cluster, export the kube config, basically like the config that you are using to authenticate with the cluster. You can get the clusters, load an image to the node, and then basically that's it, right? Perfect. So what we'll be using today will be basically we're going to create a cluster, we're going to delete a cluster, we're going to get the clusters, and we're going to load images into the cluster. These are the four that we'll be using most I think here. So let's start with get clusters. So again, Kind is the utility. If you do get, right, if you want to see more on the get, you can now add the helper again. You see the get flag. You can get clusters, you can get kube config, you can get the nodes. So if I do Kind get nodes, I don't think I have any cluster. So that's gonna fail. I don't have any cluster running, but I'll do Kind get cluster. So it's trying to hit it. So let's do Kind get clusters. So no Kind clusters found. So definitely you cannot get any nodes. So no Kind cluster found. So we're now going to create one. So we have the power to create a single node cluster, right? Or a multi-node cluster, right? So single means when we do the Kind create, we're just going to get a single Docker container, which we are going to work in. And the other one, the multi-node means here, we're going to get one or more, right? So it can be two, can be three, can be four, five, as much as your machine can hold, right? So here we are just going to keep it simple and do a single node, but I provided the documentation on how to do multiple nodes, right? So single node, we're just going to do Kind create cluster. We provide the name flag for the name of the cluster. We are going to call our storm. But if you want to do multi-node, you have to use this particular configuration. So here, a sample multi-node cluster config file. To add more worker nodes, add another role. So if you look at the role down here, worker, so this worker guy is a slave, control plane is a master. So if I want to make this 3, then I'm going to duplicate the whole of this room plus worker, do the same thing, and that becomes what? 2 workers, 1 control plane. If I duplicate it again, it becomes 3 workers, 1 control plane, and so on and so forth. So when you are done, instead of doing kind cluster create, provide a name, you rather do kind create cluster config. So I'm using this config to do multi-node. So for multi-node creation, you go with config. For single node, just go with the name, right? So in order for us to get going quickly, we're going to do single node. So if I do kind create cluster, I name my cluster or in the documentation it says storm. So kind create cluster, storm. Create a kind cluster for me and name the cluster storm. So that I click on it. So what it's basically doing is right now is that it's going to pull the kind node image, right? When it pulls the image, then the image will now be used to bootstrap. So bootstrap basically means that it's going to use that to talk to my Docker engine and then use one Docker container, right, to create as my Kubernetes cluster, right? Because I'm doing a single node, it's going to be a single container. So now you can see the status of what is going on. Now it's preparing nodes, it's writing configuration, it's starting the control plane, and installing the container network interface called CNI, installing storage class, and tada, we have a whole kind cluster. And this works as any production grade Kubernetes cluster. And it's just a few caveats that you will want to have on your cloud provider, but nothing else. Perfect. Now we try one more time, kind get clusters and see what we have. We have Storm. Before we had nothing, now we have Storm, right? Now from there, we can then use the kubectl utility. So I think by default, if you install kind, it comes with kubectl as well. Yeah, I mean, you can try and see what you get from your side. Perfect. So I'm going in and just now use the kubectl utility. So that one is a way to talk to your Kubernetes cluster. Let's get a difference. Kind is to create your cluster and manage the cluster. kubectl is a tool to talk to the objects or services or items within your Kubernetes cluster, right? So this one is like managing the resources in your cluster, right? When I say resources, your deployment, your storage, whatever. But for the kind, it's just to manage the cluster itself, like to delete the cluster, create the cluster, those kind of like cluster related stuff. So kubectl, so the simplest one that comes to mind is what get nodes. Get node means let's see our virtual machines, and tada, it gives me storm control plane. So if I had done a multi-node, you would have seen that it would have created storm, I think, worker 1, storm worker 2, storm worker 3, and so on and so forth. So it would have 2 or 3 or 4. Because it take quite some time to do multi-node, let me try doing multi-node in the background while we continue, okay? I'll try doing multi-node in the background. Let's see while we continue so that we can have a feel about how it works. So here is a 2-worker node. It's going to be called MM. That's KTech Hub CEO's name, Mumin Mohammed. So cool. Let me try doing that. Just take some time while we, I think, proceed with our session. Let me just add a tab here. Right. So in here, I want to do kind create cluster config is going to be config. Perfect. So I'm starting a different. Okay. It's taking some. I mean, it's going to be very fast. I preloaded the. If for any one of you, if you try to create your first cluster, it may take a while because that's the first time it's loading the kindest node. They call it kindest, but that's kind. The kind node image. I mean, for the first pool, it usually takes time. Second, it just use a cache one within your local machine. That's it. So, but now I'm doing a multi-node right now. So it can continue while we move to the other tab. Perfect. So what is next? Now we've been able to create a cluster, and yeah, you can export the kubectl. I mean, we don't need this automatically. When you create it, your context will just change to that, right? So let me try one more time here. If the context has changed, yeah, the context is still there. Okay. Perfect. So, sorry if you're seeing me using K. I'm just so kubectl is the starter utility, right? Let's say we're getting nodes. Oh, sorry, we're getting nodes. Now, what I'm doing is that I just create an alias and I say I don't want to be writing kubectl. K equals qctl. That's what I'm doing, right? So that I can now do instead of qctl, I get k gets nodes just to make it much more clear. That's all. Perfect. So now let's move. We are jumping the deploy internet controller. We will not build for now. I mean, that's for advanced usage, but we hope in the near future when we have our second meeting again, we'll probably go through those ones. So, what next? Deploy a sample app. Now that we have our Kubernetes cluster, right? Okay, let's move to the other way and then just to confirm. So now the other one too is app. That's the multi-node cluster. So if you do kget nodes, right, you see we have M control plane, MN control plane, and then MN worker. So this is a two-node cluster, right? That's a two-node cluster. So as I said, you can make it 3, you can make it 4, you can make it as so it's just a normal simulation about how your production environment will look like, basically. So, but we're not going to use this, we're just going to use a single node to get things going quickly. So we then use this particular guide kind, right? Delete cluster. So we call it the cluster called MM, and tada, it's going to wipe up those two containers, and just like that. So if I do kind get clusters again, we only have what? Storm and no longer MM. Perfect. So we're going to now deploy a sample app. So this sample app can be done in multiple ways. We can do it what we call the manifest file. We can do it on the fly, right? So we'll start with on the fly. So what I mean by on the fly is that we have a very simple command. So we can use the kubectl, right? And just say run, right? And then we provide the name of the pod that we want to run, the image that is going to use, we call it nginx, and the port that is going to run. Let's say nginx, all we know is only support 80, right? Only support 80. We just do that, and now we now do get ports, container creating, get port again, container creating. Then we just add a W flag to keep on watching for us, right? So it doesn't exit. So this is like a very normal way of running a pod on the fly. What I mean on the fly here means you're just talking directly. You're not declared. So we normally call this imperative way of creating resources. Imperative means just doing it on the fly and talk to the API server. And the other way is declarative. So declarative here means that what you can see on my right hand side here, which is creating a manifest file, like specifying the kind of resource, what resource port, what resource service, what resource ingress or config map or secret or stateful set or P persistent column or persistent column claim or storage class. All those are resource names that you want to use, right? Perfect. So sorry for that noise behind the scene. So this is the imperative way of creating a pod. We just run nginx. Let's wait for to see if it goes through. But because it's the first time we're doing this, we are pulling the image. It might take some time, so we can probably just do describe pod to see what is happening. So there's a connection refused. Couldn't get current service API group. Let's get HTTP localhost 8080 API timeout. Where do we specify the right host of port? Okay. I think I'm getting something like that. So let me try another image and see if we get to make sure the all the nodes. I think the nodes are all up. Yeah, I mean that's normal. Let's okay. Okay, that's the old. Yeah, so I will not confuse you guys, but because I deleted the other one, I need to switch to the new cluster that I'm working with. Perfect. I was in the old cluster. Perfect. Sorry. It's normal we will troubleshooting together. Perfect, that's it. So started container engine next, it pulled the image, it started the container, and one-on-one is ready. A second. Okay. Sorry. So that's it. We just looking at the status of the container. That's it. The container was assigned to Storm control plane. It pulled the image. After that, it created the container nginx and then started the container nginx. Perfect. That's it. So it's now running. So this is an imperative way, but I mean we're going with a declarative way. So what I just did here, we can transfer that into this guy here, right? So let's see what it's next before we do that. Perfect. So now what I just did over here is the imperative way. So I'm just going to cancel that, right? I'm going to delete the port, then that's called nginx. Right. So now the other way around is that I can just copy whatever I have here, right? So let's say I can just copy everything here, and then I think I need the image. Let me just copy from here to there, get things going, and then let's start it in the nginx.yaml, right? So the image, I think we can just I think we just call it. I think that should be nginx. Let's call it nginx. Right. So this is the declarative way. We're putting it inside the manifest file. So the kind is we're creating a pod. So this pod, again, for testing purposes, don't run only a pod object in production. So this is like in production, we don't want to use pod. We use a pod deployment so that we have an object that will basically control and monitor and scale application. So this is for testing purposes. So kind pod version v1, we have the metadata storm. Containers is called storm app. The image is nginx. Perfect. So we save this guy, right? We call it nginx.yaml. Then we can apply it. We now do kubectl apply the file. What is the name of the file? Nginx. Ta-da! That's it. Then we get our ports again, and then create it like the way we did the command line. We check here means you are describing it. Sorry, this time around we are calling it storm app, not nginx. So you do storm app, then you see that created container, blah, 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 blah. So everything seems to be fine. If you get the ports again, realize that that's it. So back to the documentation, we come to service data by say, what we did is that kubectl apply f sample app, right? And then check deployments. So deployment means just do get ports, you find the port, or get services. But this time around, we'll be doing the service later, right? So this guy here, the image here is a hashcop image that take an argument, and the argument is just put in the text flag. Whatever you put here is what the container is going to output. So in here, I wrote, hello world, this is Storm Kubernetes kind app. So yeah, that's it. So that's it, and I think we have our application running. So right now, the interesting part is down there. No, come over there. No, that's fine. Now the interesting part of deploying this application is now to see how your application is doing. So right now, you can see the Storm app is live, but how do we check if it's a web application, especially if it's a web application like using Nginx or Apache or anything of that sort? If it has data on the internet that you want to render, then that's how we use a tool called or an object called port forward. Now this Nginx, we all know what appears in Nginx, right? When you have your Nginx, what normally appear? We know the message. So let's find out the message. So I'll do kubectl port forward. I mean, a very key word that we all know, or we should know, or probably we've heard about. If not, that's fine. So port forward, then what am I trying to port for? I'm trying to port forward something from my local machine. That's from the Docker network to my local network. So I'm port forwarding the port that I named what? Storm app. But on my machine, I want to access it on 2024, right? My machine port is 2024. But the actual application within the Docker itself is actually on port 80. Nginx is on port 80. So that way. So if I go to my local machine, right, and then go to 2024, we are expecting, I mean, the anticipation that we should see what? Welcome to Nginx, right? So this is literally when you have a new Nginx application, this is what you're actually going to see, right? And then we are going to update this particular application and show you how, in fact, you can override this particular one and redeploy your own application. So this kubectl port forward, and then the name of the port, then give a local port number, and then map it to the port of the container. Now let's go back. That's this Nginx. Now you guys have the GitHub. I think you want to test out what is exactly there. So let's test out this guy here. So I'm going to kill it, right? So we have sample app. So we're going to cut sample app and see what is there. Because in the documentation I said we're going to use sample app.yaml. So here we name it storm app. We're using HashiCorp, and as again I said, it's taking an argument. So you can change this guy. You can change the hello world to anything that you want, right? So I did hello world. This is a storm Kubernetes with kind app. Then I have a service that's an ingress. So forget about this one for now. But let me deploy that one. So apply sample app. So it's going to override the next one because it's using the same name, right? That's it. I get my port. So okay, storm up. That's fine. Let's get port again. So that's it. Storm up one done. So you guys, when you're trying to do it, what you're going to do is use this guy, right? I'm just trying to show that it works before everything is messed up. So we are going to do the same thing. Port forward again. This time around, we're doing storm up one. Let's say we're doing 2019 and then mapping it to what? To the port number. So the port number check well. Very important. So in there, if you go to Docker Hub and check the image, you see the port number, right? So the port number is actually 5678. Very important. So 5678. So I'm now mapping 2019 to 5678, right? So 2019 and tada. So this is my application. Hello world, this is a Storm Kubernetes with Kind app. Again, as I said, if you go in there, right, and modify any of these text, the text will show. So hello world, this is Storm Kubernetes with Kind app, right? So to prove to you that if you edit it, that will change, we can do something like sample app. Right, and then maybe let's do let's take this out, this guy, right? I think what can we do? There is thunder and storm. Let's do it that way. There is thunder and storm. So hello world, there is thunder and storm, right? So we save this guy. So now what should we have? This is Storm Kubernetes we kind of have. So we modified it to the thunder and storm. So we're going to reapply again. Ta-da! The port invalid spec contains image. Okay, that's for the image part. That's fine. So let's take one more again. We're probably missing something. I think text. Okay. And we seem to be good to go. So let me delete. Let me get the ports again. Storm up one. Yeah. I mean, one interesting thing about development is we don't pretend that everything is working fine. If we pretend, you're not being honest to yourself. I think if things get worse, I'm just going to pull out ChatGPT right now. Yes. It's normal. We do it, and you should be proud of it. You should be comfortable with it. The problem is you should learn how to debug your own stuff. Like get into the issue, get into the problem. The fact that you can debug it just shows that you know your stuff, right? And I think while just deleting this, a friend of mine that went for an interview and then they just gave him a task, and then after 3 days he brought in the task. They were like, okay, we know you had the task right. Tell us how you were able to go through it. That's the task, right? They wanted to see how did you go through it? What's the thought process about that? And that should be normal. There's absolutely nothing wrong about that. Yeah. So not expecting to see everything just being So I deleted the old one, did the new one, and that's it. So I do another port forwarding, and then okay, so yeah, just doing some cleanup so that we can go on a clean state. Okay. 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 Listeners fail to create with the following errors. Unable to create listener error listen TCP 2019. File address is unable to create listener error listen to unable to listen to the requested 2019 code. Okay.
Port
Oh, okay.
already in use.
Already used. I don't think I have any. Okay. So okay. Let's see. Let's see. Is it X? Oh, I think it's Linux that use the define the processors. Never mind, that's fine.
I'm using
So
Mac.
yes, okay,
They are using Mac now.
you know, yeah, Linux is king. Yeah, okay. Let's try the code again. Okay, okay. Deleting. This is hard actually. Let's get these guys out. Okay. That's fine. Yeah. So yeah, I know I'm doing everything from Vim. I advise you to do this on VS Code so that you don't have any problem. That's just where the issue is coming from. Just do it on VS Code so you're on a much more safer side. Let's just do that right now. Why not? So I'm dragging in it here. Yeah. So we're going to sample app. And then I think we're good to go. Now let's switch in. Okay. Sample up.yaml. Okay. Okay, let me just change this guy. Make sure. Oh, okay. Maybe I didn't. Yeah, I know. So I didn't kill it. It's like I exit kind of like when you have dangling ports all around the place. I know what is happening. I'll handle this later. So let's do 2020. That's it. So it's now hello world. There is thunder and storm. So that's just what I wanted to prove to you. So you can keep on changing this guy to see how it looks. But we are going to have a part that we are going to really actually create our own local app, and that's the next part. Now check deployment. So here is just we're checking the port to see if it's running or not. After we port forwarded the port, I'll take this guy. Now the interesting part is, as a DevOps engineer or as DevOps enthusiast, what you would actually want to do is you want to actually have your own Django application, Flask application, Next, Vue, whatever. You build it. Now you need to create a Docker file for that. Build it, tag it, push it, right? Pull it into the cluster, and then tada, we call it a CI/CD pipeline. So we'll do a mini CI/CD, but it's going to be done locally. Perfect. So inside the repository, I hope by this time you all had access to it. We'll have what you call Docker file, right? And inside the Docker file, it's just doing two lines. One, we are pulling the nginx Alpine image, and then we are copying our own custom index.html into the user share nginx HTML.html. So we are going to override. So if you remember, when we did the welcome to nginx, well, we are going to override the welcome to nginx with our own custom index.html. So in here, we are going to have index.html. What is it? Over there. And then we're just going to have a simple HTML with H1 header title for stormy day, number 2, hooray, that's all, right? And then we're going to build this Docker image, push it inside the Kubernetes cluster, and deploy it, and then see it come live. That's what we're going to do right now, right? So, perfect. So in the next document, what is that? Okay, we're done with that one. Perfect. So now let's go back. We're going to do Docker build storm image, right? So we're going to build that image. So now let me make this quite bigger so that you see the entire process. Right. So I'm now going to do Docker build storm image. So you have to make sure you are in the same direction as the Docker file, else you need to explicitly use the what? The -F to point to the Docker file location. So my Docker file is in the root directory, and I think that's the same thing upstream, right? So I'm going to do Docker build, right? And then tag my Docker file. That is the Docker image that's going to build. Storm image. I'm doing mine with, let's say, 4. I've done 1, 2 already, so let's say 4, right? So it's just going to do simple. Pull this image, copy this index.html. That's it, and tada, I'm good to go. That's all that is doing, and it's pretty much very, very simple. And tada, it's done. Now, what's the next step? Now I'm going to load this image. What load means here? I'm going to push the image inside the Kubernetes cluster. So it's simple. I'm going to do kind, right? I'm going to do kind load Docker image. Then I specify the image, then the name. Name here means name of the cluster, right? The name of the cluster. And then before, let me do this. So if we want to know the name of the cluster, it's pretty much simple. Just do kind get clusters. Get clusters, kind, not key. Right, so storm. That's it. So when you do load, you are loading into the name of the one, the cluster. The cluster is called storm, not MM. MM has been deleted. That was a multi-node one. So ours is called storm, right? So I'm loading. Loading means I'm pushing the image into the cluster. Now in a normal CI/CD pipeline, this will be done in your whether Prerequisites CI or GitHub Action, where you are actually pulling the image from your what? Your container registry. It could be Azure container registry. What's the name? AWS, that's ECR. It could be AWS ECR. It could even be Docker Hub itself if you're pulling your images from Docker Hub, right? So here we are actually pulling it from our local machine into the Kubernetes cluster. Let me put it that way. Now that is done. Our next step is what? We can exec into the node and see the images, but that's not going to be done right now. All right. Now the next step is now. You remember you built the Docker image and then we name it whatever. Make sure you are taking this same image, right? And then go to a file called local image app.py, sorry, the YAML. Now go there and change that to match with what you are pushing to your cluster because that's your latest application, right? Now we have your service. As I said, service is the door to the pod. We could have used deployment, but that's fine. And then we have the ingress. We're not going to do ingress for now. That will be in a later day. So that is done. When that is done, then you can then apply, right, sample local image.yaml. Again, what is happening? Update port will change false other than spec containers image. The containers image. Okay. We're probably missing something. Which the opportunity identical fields. Okay. Makes sense, makes sense, makes sense. Why? Because we already have Storm one application one, and let's delete that guy because they're all having exactly the same name. We check this guy, Storm app one, this guy two, Storm app one. So let's delete the first one. So we have way for the second one. Or if you want better, so you can just change the name and you're good to go. Yeah. So let's give it a second to purge it. And we are almost an hour and 80 minutes in. We hope this will finish in the next like 10 minutes. So we can rest, take a break if you have any questions, and then we can reshare all the resources. Yeah. So everything deleted. Then we need to apply again. And this time around, we are good to go. Perfect. So we try to see the ports, and then the ports are running. Now, moment of truth. We do the another port forward, and then mind you, make sure that the port number of nginx is matched here. Right. So you go to localhost 2020, and what is the expectation? We need to see this index.html rendered there. Right. Ta-da! It is a stormy day. So that is our new application. So this is just there's nothing outside of CI/CD from what we've just done. Just that we've done it manually. And CI/CD automation, you just tie everything up together, and you are good to go. Now, let's update the application. That's now the most interesting part for you to see. Now that we have application one, it's a stormy day, hooray. Now let's come here and then update the application. Maybe let's add an H2 tag again and say maybe server under maintenance. Maintenance. Right. Let's do something like this. So now this is an update of the application. So what I'm going to do right now, so watch what you have here. Is somebody is hooray, right? Now we're going to build again. So that's why how a pipeline will now work. So that's where this time around we're making the push to the remote server, maybe on GitHub, and then GitHub is now going to pick up changes like that. So in GitHub Action, we now have something like Docker build again. We have a new tag, right? After it builds it, then it pushes it to our container registry. Very simple, right? And then the same thing we are loading. That's kind of Docker. And just take a look at how we're making we're changing the tags. So pipeline, that will be very dynamic, not complicated. That is done, right? Then in our application, we just need to update the default 5, and we're good to go. So we do apply again, and we're good to go. So it's going to delete the old ones, and then the new one is going to come up. Let's verify that we are on a good. Ta-da! Server under maintenance. So that is how we updated our application. So again, in a pipeline, everything is just automated. Very simple. If you follow this way, like if you follow from updating the application and then tagging it and then pulling it inside the Kubernetes cluster, like trust me, bro, you will not miss anything. That's the same thing, never changes. So I think we will put it here. Whatever is there, we have advanced. I think we'll not treat this guy now. So we have an advanced. Advanced mean here we could actually make our load balancer. I mean our service to be of type load balancer, so it can be public on an IP. But last time I checked, Metal P is what they use, but it has now been deprecated. and then a new one called, I think, Kind Cloud Provider, CL, Kind Clouds, KCP. That's a new one that's been out, still in beta moment, beta stage, and I think that's what we'll be doing the next time we meet again. But aside that, I think we've actually done whatever it takes, and this is the beginning. As again, that's the title: Kubernetes for beginners or absolute beginners. The code is readily available on the GitHub group. Let me copy it one more time. Maybe if you want it again, so you can fork it into yours or clone it and work on it as much as you want. Yeah, and then we have the WhatsApp group. Those people want to join, they can also join. Perfect, team. That's it. Thank you for joining. And any questions before I think we call in Mr. Mumini to give his remark? Thank you.
Actually, the recording is huge. It's like 1 hour. So let me stop the recording here.
Yeah, that's fine. That's fine.
Okay.